Hello friends, I am back again with a new problem on binary search. The problem that we'll be solving today is find first and last position of an element in a sorted array. So if you are given an input array and a target value, you basically need to output its first and last position in that array. Okay. And if the element does not exist in the array, so if the target is not present in the array, we basically return -1 -1. So we basically return a array with two elements, which is -1 -1. This indicates that the start index of that element is -1 and the end index of the target value is also -1, which means that the target value was not present in the array. Okay, now let's consider these examples. So if you are given an array like this and you have to look for target value 3 in this array. Okay, so the start index for target value 3 is 2 and the end index for the target value is 5. So the output of your method should be 2 and 5. So it should basically be an array with two elements. The first element should be 2 and the second element should be 5, which means that the start index of this target value is 2 and the end index for this target value in the array is 5. Okay, now let's take another example where you basically have to look for target value 3 in this array of just two values 1 and 2, right? In that case the output would be -1 and an array of two elements which will be -1 and -1. Okay, now let's jump into the code. I have created this class element position finder. It contains a main method which I'll be using for testing my code. Okay, the main job here is to implement this search range method, which will actually return the first and last index of this target element within this nums array. Okay, so let's start. First, I'll be checking for some edge cases or boundary conditions. So I'll basically check if the num is equal to null or its length is 0. So in that case, I'll basically return okay, because this is the case when your array does not have any elements. So in that case you cannot search for this target value, right? So we'll simply return an array with two values -1 and -1. Okay, now I will basically start looking for the leftmost index of this target value. For that I will create a helper method. Okay, this helper method will actually be performing binary search on my nums array. Okay, and it will be finding the target element. Okay, but it won't be exactly the normal binary search code. I'll make some modifications to it. Okay, so I will name my binary search method as search element. Okay, then I'll basically pass, so I'll pass the nums array and then I'll pass the target value, the first index, okay, the leftmost index of my array. I'll pass 0 and then the rightmost index is length -1. This is the last index of the array, and then I'll introduce a boolean parameter which basically says whether we are looking for the leftmost index of this target value or for the rightmost index. Okay, so let's take this example. Okay, so suppose I'm looking for this value 3. Okay, and I'm in mid of my search and my mid value is currently equal to the index of this 3. Okay, this is not the first or the last occurrence of 3. Okay, I will either have to look on its left side or I'll have to look on its right side. Okay, and basically this parameter, this boolean parameter, actually denotes that whenever I am at a particular index, with the use of this parameter I'll basically check if I have to go on this side or I have to go on that side. Okay, now I will implement this method in a moment, but I will use the same method for finding the rightmost index of this target value in the array. Okay, but here the leftmost index as an optimization, you can make it equal to the index that you got in the previous step, right? Because you have already searched for the first occurrence of this element, right? So you only need to look on its right side now. Okay, and here you should basically say false, because here you are looking for the rightmost index of this target element. Okay, one more condition that I should introduce here is if left index equal to -1, then this means that this target element is not present in this array. So in that case, you will basically return an array with 2 elements, with the elements being -1. Okay, and at the end I'll basically return an array with left index and right index. Okay, now let's implement this method. I'll basically rename these variables. I'll name it as left, I'll name it as right, okay. So now let's check for some more boundary conditions. Okay, what if start equal to, or sorry, what if left is equal to right? What if your sub array or the input array just has one element? Okay, so if it just has one element, you basically check if nums left is equal to target. In that case we return left. Okay, otherwise we return -1. So basically this condition denotes when the array you are looking at or the sub array you are looking at is of size 1. Then you basically check if the index, this left or the right index, the element at this index is equal to the target, you basically return this index, otherwise you return -1. Okay, the other condition that we have to check for is if your left is greater than right. If you are wondering in which case this condition can occur, then you should definitely check out my first video on binary search. There I have explained it in detail. Okay, so if left is greater than right, this means this is an invalid case, right? Your sub array is not valid. Okay, in that case I'll simply return -1. Okay, now let's start the logic for our binary search. Left plus right by 2. Okay, now I check if my mid element is equal to the target. Okay, in that case I'll basically check if I have to look on the left side, or I'll write some logic for the else block as well. So this, if this is left, means, as I have already explained, that in this array, suppose I am at this index, right? This is left will indicate that we have found the target value in the array. So the target is present in the array, but we are not sure if it is the leftmost or the rightmost target value. Okay, so we might need to search on this side for finding the leftmost, or if is left is equal to false, then we basically need to search it on the right side. Okay, so if it is left, then I basically check for one more condition where I say if your mid is equal to start, is equal to the left. Okay, in some of the programs that I wrote earlier, I named these variables as start and end. Okay, so that's why again and again I'm using start for left. Okay, so I check if mid is equal to left, means this is the first element of your subarray you are looking at. Okay, so this is the first element either for your array or for your subarray. Okay, in that case you cannot go on the left side, right? Or your nums mid minus 1 is not equal to target. Okay, so basically this is the case when you are already on the leftmost index, and this is the case when the value on the left side of your mid element is not equal to target. In that case you simply return mid. Okay, but if this is not the case, then we look for the element on the left side based on this flag. Okay, so I'll be recursively calling my method again. But now my left stays the same, but my right, it becomes mid minus 1. Okay, I will perform the same check for is right also. Okay, so when we have to look on the right side of the mid value, but here I'll be checking if mid equal to the rightmost index. So if it is equal to right, or mid plus 1 is not equal to target, then we simply return mid. Otherwise we search on the right side, so it becomes mid plus 1 and it becomes right. Okay, so this condition says that if mid is the last element of your array, okay, or the sub array you are looking at, or if the next element to mid is not equal to target, in that case you simply return mid. Okay, now if for the else block of this condition where the element in mid is not equal to target, in that case we basically check if mid nums mid is less than target. So okay, so the element at mid is less than target. Okay, in the else block will be when it is greater than target. So if it is less than target, okay, if the element at mid is less than target, then we need to look on its right side. Okay, then we basically call this here. Okay, and if the mid is greater than the target, right, so we basically look on the left side. Okay, so if your mid element is less than the target, we look on its right side. But if your mid element is greater than the target, then we basically look on its left side. Okay, our code is complete now, and let's test our code. So okay, yeah, we are good to go. So let me run it. Okay, so for the first array we are looking for value 3, right, and it is present at index 2, right, and it has only one occurrence, so this result is correct. Okay, now for the second input we are looking again for value 3, but here we have multiple occurrences of it. Okay, so this is at index 2, this is at index 5. Okay, so even this is correct. In the third case we are looking for value 8. Okay, and 8 also has multiple occurrences. Okay, so and the first index is 7, right, and the last index is 9, so even this is correct. So friends, this class is complete now. I'll check in this class into my GitHub repository, and I'll provide link to my GitHub repository in the description section of this video. I'll also provide a link to the coding portal where you can go and solve this problem. In the next few videos, our main focus will be on binary search. We will explore different problems related to binary search. If you like the content of this video, please like and subscribe, And if you have any suggestions for me, please do put them in the comment section of this video. Hope to see you soon. Goodbye for now.